This video summarizes learnings from an AWS engineering blog on how ProGlove scaled to 1 million Lambda functions on their platform. Scaling that platform took them from 1,000 Lambda functions across 50 AWS accounts to over 1 million functions across more than 1,000 accounts. They didn't get there with one big redesign. They hit a new wall roughly every order of magnitude. Here's what broke and what they changed at each stage. Early on, one pattern repeated across the whole platform. 5 to 15 AWS Lambda functions per microservice, orchestrated by AWS step functions, with Amazon EventBridge routing events between services and Amazon DynamoDB as the data store. Every microservice bundled all of it into a single AWS CloudFormation stack, so one deployment always meant one consistent unit. But a shared multi-tenant setup means one noisy tenant can throttle everyone else's Lambda concurrency or API gateway quota. Their fix was one AWS account per tenant. A step functions workflow running in the management account uses AWS Organizations and cross-account Lambda invocations to spin up a fully isolated new account in under 15 minutes. At hundreds of accounts, a subtler problem showed up. Every account's scheduled Lambda functions ran on the same rate of 5 minutes, all synchronized to the top of the minute. Hundreds of accounts hitting shared services at the exact same instant looked like a coordinated denial of service attack. The fix was jitter, randomized offsets so requests scatter across the window instead of arriving together. Here's a cost most teams don't plan for. Forwarding logs and metrics from every account was costing about $3 per account per month, and at scale, that nearly doubled their entire cloud bill. The fix was learning to differentiate between high and low priority observability data, and only actively forwarding the priority data. They also let an idle account's monitoring drop to almost zero after a period of inactivity, watching just a small set of basic metrics instead of the full set. Together, that brought the cost down to around 70 cents per account. True scale to zero turned out to be harder than it sounds. Amazon SQS queues cost money just by being pulled, even when idle, and giving every account its own dead letter queue meant pulling thousands of queues for nothing. They removed SQS from the main EventBridge to Lambda path entirely, and routed failures instead into one centralized, shared SQS queue, acting as the dead letter queue for every account, pulled once, not thousands of times, alongside async events dropped and concurrent executions as safety net metrics. AWS CloudFormation stack sets, which had handled multi-account deployment for years, started hitting a real performance ceiling once the platform crossed 1 million functions. Errors started accumulating significantly. The team built their own internal serverless deployment engine, with a centralized step function state machine acting as a single pane of glass for tracking every deployment and retry. By this point, 20 separate microservice repositories had become a governance problem of their own, so they were consolidated into a single mono repo with shared tooling, shared security scanning, and centralized runtime upgrades. And one honest lesson survived every phase. True scale to zero doesn't really exist. Monitoring and alarms keep a small cost running even at zero traffic, so the real target is almost zero, not zero.